Let us solve this Jamb physics problem together. It says an object of mass 20 kg slides down an inclined plane at an angle 30 degrees to the horizontal. What is the coefficient of static friction? So let's get into it. We have, let's draw our inclined plane first. So let this represent the inclined plane. Good. And let's have a mass of 20 kg. So let's say this is the mass. The mass is 20 kg. Of course, the first thing we know is that the weight of this object will be acting downward. So the weight is 20 kilograms acting downward. And then since we know that the weight is mass times acceleration due to gravity, we've been given 10 here. So that will be 20 times 10, which is 200 newtons. Now let's look at the other thing that is happening in this problem. It's sliding down at an angle of 30 degrees. So this is 30 degrees. This is 30 degrees. What we know is that there's going to be a normal reaction on the surface of interaction between these two, the inclined plane and the block itself. There's going to be a normal force. And what is a normal force? A normal force is, or normal reaction, whichever one you like to call it, is going to be a reaction that is perpendicular to this surface of interaction. So normal force will not go straight up like this. Rather, it wants to act perpendicular to this line here, because that is the line, that is the point where these two are in contact. So the normal force will go in this direction, will go like this, yes. So I will call that normal reaction, I will call it R. I'll call it R. Then, what other information do we need here? This is sliding down. Sliding down means that, and we are looking for coefficient of static friction. That implies that this surface is not a smooth surface. What will be the direction of our frictional force? To get the direction of frictional force, it is always opposite the direction of motion. Please take note, opposite the direction of motion. So if it is sliding down, that implies that the direction of friction will be going upward. So let me denote frictional force with Fr. With this now, we are looking for the coefficient of static friction. Even though they say that this object is already sliding down, we wouldn't need to really consider that sliding down because we are looking for coefficient of static friction. So what we would consider is the moment just before it starts sliding down. And that is because we are looking for coefficient of static friction. If we were told that we are looking for the coefficient of kinetic friction, then we would have needed an information about the motion of this object downward, whether it's acceleration or the rate at which it is speeding or losing speed, whichever one it is, or if it is moving at a constant velocity. But that's not needed here. We just need the information that is the coefficient of what? Static frictional force. And we don't need the sliding down. We only need to consider that it is just about to slide down. To do this, we need to redraw all these forces here, the R, the 200, and the Fr. So what I want to do is that I want to draw a form of completion to the part of R. And if you do your analysis very well, this angle is always equal to the angle of inclination. This angle is always equal to the angle of inclination. So if I make the R path, I will make it the vertical. Let's draw that. That's the vertical. So we have R going up here. That implies that on the left down part, let me draw that here. So we have the 200 Newton coming up and at an angle of 30 degrees. So let me quickly put an horizontal line right here. Now, on the right of this side, so we have the force of friction acting in this way. And with this, we've been able to draw all our forces. Next thing to do is to resolve this. So let me just put that down here. For the vertical component, let's resolve the vertical component first. For the vertical component, R is going up, so we have positive R. Then the only other thing we have there, FR is not in the vertical region, so we leave that. Now the next thing we have here is 200 Newton, which is acting downward. That means that it will have a minus sign, so minus 200, but we have to determine whether we use sine or cosine. The angle 30 degrees is made with the vertical. The angle 30 degrees is made with the vertical. When you are doing a vertical axis and the angle is made with that vertical axis, then you use cosine of this angle. So that will be cosine of 30 degrees. And because from this place, there will be no movement in this upward direction. At least the object is not bouncing up, neither is it sinking down. That implies that it has no acceleration in this direction, and hence this will be equal to 0, because it's supposed to be mass times acceleration before, but because there's no acceleration, we equate this to 0. And what does that mean? That means that R will be 200 cosine 30 degrees. So you should know this cos 30 degrees already. So that will be 200 cosine of 30 degrees, and that will give us 100 root 3. So that's 100 root 3. That's our R. Now the next thing we need to look for here is we need to look for the frictional force. So let's do the horizontal. For the horizontal now, we have the frictional force going to the right, so that's FR. Anyways, I always say that I prefer to use the direction of motion as the positive side. Since this object was sliding down, that implies that the direction of motion will be like this, will be in this path. This will be the direction of motion. Hence, 200 Newton is like in the direction of motion. So I can use the direction of motion now, which will be 200 Newtons, but it is not directly on this axis. So that will be 200. The angle is made with the y-axis, I mean with the vertical axis, but I'm dealing with the horizontal. When you have such that the angle is made with another axis other than the axis you are dealing with, you will use sine of the angle that you have been given. Then that is for the 200 Newtons. Minus FR is in the opposite direction, so minus FR. Since we are looking for coefficient of static friction, instead of this thing to be equal to MA, A will be 0, and that implies that 200 sine 30 degrees minus FR will be equal to 0. And if we do this very well, that means that FR equals 100 Newton. Finally, the coefficient of static frictional force will be the ratio of the frictional force to that of the normal reaction. And the frictional force is 100, and the normal reaction is 100 root 3. So this will be equal to 1 over root 3. And that will be the coefficient of static frictional force. If you like, you can rationalize this. That will give us root 3 divided by 3. Any of this will go. If you want to see more videos like this, don't forget to subscribe, like, and follow. I'll see you in the next one.